Alright, so in the last video, we talked about the first special case we will meet in the regression. So in this video, we'll keep talking about the second special case. It is about transformation. Alright, so in the chapter of simple linear regression, we have already talked about this transformation, right? So we say if in the scatter plot, it didn't show very straight trend. Instead, it shows a kind of a curved relationship between x and y. Then we can make the natural log transformation of the response variable y, right? So that we'll use the natural log of y. Based on that, we get b0 plus b1x, right? And then we can interpret it with y hat will equals to e to the b0 plus b1x, right? Okay, so this is the first transformation we talked about. We say it is natural log transformation. All right. So again, for in the multiple regression, we still can do the natural log transformation. Still remember when we check the assumptions before we do the hypothesis test, right? The first assumption we need to check is about the linearity condition, right? So we need to make sure every explanatory variable has the linear trend with the response variable, right? So the same thing here. If you see any variable shows kind of the curved relationship between any variable with the y, but you think it is still very important to make the prediction about the response variable. You want to include this variable into this regression. Then for this case, you can make the natural log transformation about x. Remember, right? So here we make the natural log transformation about the y. But for the multiple regression, you cannot make the transformation about y. You need to make the transformation about x, right? So that you will, so in our data, right? So you have the price y, one column. You have x1, x2, x3 maybe, right? So until, for example, xk. And then if you think, okay, x3, this variable shows a curved relationship with the response variable, but you still want to add this variable into the regression. So what you can do the natural log transformation about this variable, right? You can create another column just to calculate the natural log of each observation in the data. So that's when you make the regression, about x1, x2, and not this one. Instead, you include this in your regression. Right, so this is called the natural log transformation. All right, another kind of transformation you can do is to square the explanatory variable xk. Right, so it will be the same idea. So for example, you have the response variable y, one column, you have the number of bedrooms, right? You have the living area. And then I think maybe the number of bedrooms, which is x1 squared, if I square it, I want to know whether it shows stronger relationship with the house price, whether there is a stronger relationship if I just add this term into this regression. All right, then we'll have one more variable. you can just calculate the x1 squared for each observation based on this column. All right, okay. But the difference is if you want to add the squared term into the regression, you need to include the original one. All right, so that means if you want to add the squared term into your regression, you need to first include the original variable into the regression. So for example, if you want to add this squared term into your regression, then your population regression model will be changed to mu of y equals to beta 0 plus beta 1 x1. You need to include the x1 and then include the x2, and now you want to add this term, you want to add this square term into your regression, so you will have beta 3 x1 squared. So you kind of consider this is the third explanatory variable to predict the response variable. All right, so this is the second way to maybe for the potential improvement about your regression. And then you have this third way to improve your regression is about to add the interaction term. Alright, so it will be the same idea that you still have the response variable, you have the x1, you have the x2 variable, and now I think that maybe the interaction between x2, I calculate another term, which is the x1 times x2, will be my third explanatory variable to make the prediction on y. I want to try whether if I add this term into my regression, whether my regression is good, is better or not. Then for this case, your population regression model will be changed to mu of y equals to beta 0 plus beta 1 x1 plus beta 2 x2. This is the original regression. Now I want to add this term into the regression, so I have beta 3 x1 times x2. Right, so I just consider this term as the third explanatory variable to predict y. So your coefficient will be beta 3. Alright, so for this video, we just talk about the 3 ways for you to improve your regression. We can do the transformation about your data, about your explanatory variable. Alright, and this transformation, sometimes we also call it is the re-expression of the data. All right, so now let's try it with our data. So this is our data, right? So this is the data from the last video, right? So now I just focus on the number of bedrooms and the living area, and I want to create another column, insert column, and then I want to do a natural log transformation about, let's say, about the living area. Right, so I just gave the column's name for the natural log of living area. All right, and then if I do this, okay, so they have already got the formula of it. But here I want to specify again. So for this variable, I want the values to be natural log transformation of the living area variable, right? And then apply it, and then click OK. All right, so this is the natural log transformation of the living area, right? And also I want to make this column as the, let's say, I don't know whether it will work, so let's say this is the bedroom squared term, right? So let's try everything together, right? So bedroom squared, right? And then I assign the value of it by the formula. Say I want the number of bedrooms, and then square it. All right, so that's, then this column will be just the squared of the values in this column. All right, so we have bedroom squared and natural log transformation. And then let's try one more thing, right? So we want to insert another column, and I call this column to be the interaction term, right? So delete it. I want to change the name of this column. We say it is bedroom times the living area. All right, so this is the bedroom times the living area, and then I assign the value of this column to be bedroom times the living area, which is the interaction term, right? So we apply it and then click OK. All right, so here we have the three kind of transformation here, right? So we can make the natural log of any explanatory variable, we can square any explanatory variable, we can make the interaction term of this variable. So we can just consider these ones are the actual explanatory variables in our regression. So now I can make the regression, so fit model, and our price is still our y. But for our explanatory variable, we have the bedrooms as x1, living area as my x2, and then let's say the natural log as my first transformation, right? So it will be the third variable. And then next one, we talked about the number of bedrooms squared as my first, my fourth explanatory variable, and then the interaction term. All right, and then what? And then just run it. All right, so this is our output. Let's go up to look at it. All right, and then we will have this parameter estimates table. All right, so that means based on this table, we only have two variables are significant with the red, which is the small p-values, right? So the living area and natural log of living area. And the other ones are not significant based on with these two variables in our regression. Then these three things will not be very contributing to our regression, right? So for this case, if I include all of these in my regression, how you can write the model, right? Think about it. All right, so let's go back to the notes. I don't have the space, so let's just use this small space for our example, right? So in our example, we first the model, right? So we say it is the population model. It will be mu of y equals to first the intercept, right? And then beta 1 x1, which is the number of bedrooms, plus beta 2 x2, which is for the living area, right? And then next we talked about to add the natural log transformation, right? So we have beta 3 natural log of the leaving area, which is x2. And then next term will be the square term about the bedroom, right? So we have beta, next one will be beta 4 with x1 squared, number of bedrooms squared. And the last term will be beta 5 times the interaction term, which is x1 times x2. Right, so this will be your model. And then what is your sample equation? You need to plug in the estimates for each one in the output, right? So it will be these ones. So you just plug in the number into this model so that you have the sample equation, sample regression equation. All right, so that's all I want to talk about of the multiple regression. And then next video we will talk about our project 2, right? Because the project 2 is very kind of difficult for you, so I will do an example so that you can follow the follow my steps. All right, okay, so see you in the next video.